Welcome to Scientific Software Horizons, the podcast where curious minds in science and technology come together to explore what's next for scientific software. Each episode brings you into the conversation with cross-disciplinary experts and community visionaries as we dig into the opportunities, challenges, breakthroughs, and emerging solutions shaping the future of scientific software. From HPC to AI to quantum, we're diving into the technical leaps and the human stories behind them, the people, the practices, and the evolving ecosystem driving tomorrow's discovery.
In this episode, we travel to the United Kingdom, about 90 minutes west of London, to the historic harbour city of Bristol, England. For centuries, Bristol was famous for its maritime heritage as one of Britain's most important trading ports, connecting the city to the Atlantic world. Its historic harbour still sits at the centre of Bristol's identity. But today, Bristol is equally recognized as a centre of innovation. It's home to a vibrant technology, aerospace, and research ecosystem anchored by the University of Bristol. Our guest today plays a central role in shaping that future technology ecosystem. Dr. Sadaf Alam leads Bristol's supercomputing initiatives as Director of Advanced Computing Strategy and Chief Technology Officer at the Bristol Centre for Supercomputing, commonly known as BRICS, one of the United Kingdom's newest national hubs for advanced high-performance computing and artificial intelligence research. Since joining the University of Bristol in 2022, Dr. Alam has helped drive the transformation of research computing and digital infrastructure in the UK. She co-founded the Isambard-AI initiative and has been advancing national strategies for federated supercomputing and sustainable digital research infrastructure. Prior to Bristol, she served as Chief Technology Officer for the Swiss National Supercomputing Center and has earlier experience as a computer scientist at Oak Ridge National Laboratory, and she holds a PhD in computer science from the University of Edinburgh. Dr. Alam brings a rare combination of deep technical expertise and strategic leadership across sovereign AI, high-performance computing, quantum technologies, and data-driven research infrastructure. In this episode, she'll be speaking with our co-hosts, Mike Heroux and Lois Curfman McInnes. And now, here's Mike Heroux.
Thank you, Mike Bernhardt. Sadaf, welcome to our podcast. We are so happy that you could find time to join us and give us your perspective on HPC and AI from your role at Bristol. So you've worked across several major computing environments and now help shape the strategy for advanced computing at Bristol. When you look at today's HPC and AI landscape, what feels fundamentally different, say, compared with earlier phases of supercomputing?
Thanks for inviting me to this podcast. I'm really, really happy to be here. The way it feels different, in my view, are two ways. One is political and other is technical. So I'll start with the political side of things. So I moved to Bristol from Swiss National Supercomputing Center just over 3 years ago. And almost 1 year, like back in 2023, late 2023, there was this activity going on about having a UK AI research resource funded, which we applied. And to my biggest surprise, we got like a feedback asking us to make something bigger, which usually doesn't happen. And the request was directly coming from the Prime Minister level, because the Prime Minister at the time was hosting AI Safety Summit. And since then, never in my career, so I ended up meeting, the Prince of Wales. So AI has, at the political and societal level, the level of visibility I never ever experienced, through decades of our career in modeling and simulation side of supercomputing. So that is more sort of how it is perceived, and I feel like a privilege, but a huge responsibility to get things right. On the technical side, I feel that the leaders are outside our community. The leaders and the users are outside our like known community, in the sense that the people who are building AI, they are typically using cloud-based technologies. So when they come to our environment, and I think we will cover the cloud and AI side of things, they come with with set of requirements we typically have not considered, whether it's architecture level. So GPUs have been used in scientific computing for a long, long time. But what hasn't been done, that how do you offer them with various degrees of virtualization and readiness to scientific code, which tend to change but not change that quickly. So the rate of change, managing the rate of change in this community, which sometimes feel like it happens in less than 3 months, is on the, as a service operator or system architect side of things, is something quite different. Because we used to take a lot of time to co-design, deploy, operate, tune our digital computing research infrastructure. So these are like the two things I can share from my personal experience with Isambard-AI, and then reflecting back on working at different supercomputing, national supercomputing centers.
So on one hand, it seems like you have incredible visibility at the national level, but then on the technical side, traditional HPC, or what we view as scientific computing, is not in the driver's seat technically. How does this change the approach that we're going to use going forward? Do you consider this evolutionary, or is this like a real discontinuity, I guess, in both senses, politically and technically?
Yeah. So as you can see, the answer is not that clear-cut, because the community we are working, or communities I should say we are working with, they are under different, let's call that, financial and other pressure to kind of win the race, so to speak, if I can call it that way, where they can pour in the level of resources we can't not even dream of in the typical communities we come from, and especially in the UK. So what ends up happening is, in my view, sometimes people play fast and loose. So while we should adopt the innovation that are coming out from this fast-paced evolution or revolution in the AI world in our communities, I feel like, especially in my role working at a nonprofit university, national security, we also have we should have a sense of responsibility for public good. So I can give you a very concrete example that when we designed Isambard-AI, it was almost 2.5, 3. There was a lot of pressure to use something like NVIDIA DGX boxes, like something very custom designed. We looked at it and we say, is it the best value for money and design for a national UK AI research resource, which is going to evolve, which will be used for different varying purposes? And then we looked at all the aspects, both in terms of total cost of ownership, but also the green credentials of that. So I feel like, yes, there are definitely pieces of software stack. And for those who know me, I've been talking about modernizing the scientific supercomputing stack all the way from infrastructure level for a very, very long time. I also feel that we play a role of being responsible in public good sense on how we deploy those things, where people are doing, I call it almost like a scientific and research integrity when we deploy even the AI system in the public area. So I think that is where I think we I would say that for the answer, it depends. We just can't deploy enormous size of systems, which take up a lot of resources, but also not good for the environment.
Let's talk a bit more about infrastructure for an AI era. So, as we've mentioned at Bristol, you've helped lead the development of large-scale infrastructure like Isambard-AI. What design principles do you believe matter most when building a system that must support both AI and also traditional scientific computing?
Mm-hmm. We had another constraint when we built Isambard-AI, or multiple constraints, because we said, yeah, we could have resources, but you have to do it very quick. And we didn't even have a data center. So it was a kind of a very interesting project, starting something without a data center and a team. But the thing that was really kind of gave us this degree of freedom, not only to have the legacy part of the thing, but also we were not asked to support HPC. So we could think outside some of those constraints. So for managing the speediness of the solution, we used what is now commonly used is called container or modular data center approach, where the concept is based on shipping container, where you could just really co-design the infrastructure solution, but very quickly, as opposed to brick and mortar type of solution. It reduced the cost, it reduced the overall build and other thing, and we were able to move rather quickly in that regard. When I look at the system architecture side of things, Isambard-AI, it is a system that has been deployed at the Swiss National Supercomputing Center for modeling and simulation type of workload, as well as AI workload. But even from our supplier, which is HP, they do not in their business unit define is that as AI solution, because a typical AI solution is a way DGX lookalike box or something similar solution. These days it's called NV72. And there we said, okay, how do we provision it so there is enough bandwidth, but we have a lot more flexibility going forward in terms of co-designing software stack. So as of today, we are already still working on making sure that some of the NVIDIA pieces of software stack that typically work on their network work on Slingshot. So as a community now, I will call it, there is an investment at different levels of software stack, which I still consider part of infrastructure because it's hidden from the user, which is required. And some of this work has been going on for 7-8 years, even as part of the ECP project, such as the containerization work that we quite heavily leverage already. And I think, as you very well know, we work very closely with the E4S for some of the distribution of AI-related applications. So for me, fundamentally, it was very important that while we have this thing where we just could completely ignore what has been done in our community and build a pure AI system, I felt like this is a unique opportunity for us to bring those two worlds together. Was it easy or is it easy? Absolutely not. Is it working? Absolutely yes, because we have a huge number. I mean, we can talk later about how the system has been used, deployed across the board, and are meeting the mission targets or not. So I think it is, from my perspective, was very important to be able to say that, an HPC system can be a pure AI system. I mean, pure we could define in a different bit, but there is a long way to go still.
Can you speak a bit more about what trade-offs you're considering when serving both AI workloads and also traditional modeling and simulation?
Isambard-AI is only for AI in the UK. So it's called UK AI Research Resource. So there are two systems. One is Isambard-AI, and the allocation models are only looking for applications that are serving AI, machine learning. So the modeling and simulation or scientific computing, if we call it, for me, AI is part of scientific computing, but if we use that classification, there are a different set of systems. They are called National Compute Resource or NCRs. They are allocated differently. So there are different access mechanisms, so to speak, for AI research resource, like Isambard-AI. So we didn't have to do it, but we could if needed to. So the government knows this capacity exists should it be needed for modeling and simulation.
So, one of the big questions globally is how to make powerful AI infrastructure accessible beyond elite institutions. How should national research infrastructure balance open scientific access, industrial collaboration, and security concerns?
Yeah. So accessibility was for me a very, very big criteria, because sometimes our community can come across a little bit, let's call it elite in some sense. And so we said we should really design a system so that from application to access, like someone discovering this resource exists and there is a mechanism through which they can apply, it should end to end should not take more than 1 day. And we said this model should be based on how people access compute resources on public cloud, which is largely used for majority of the AI type of work. So we provided a lot of tooling for doing that. That doesn't mean the large scale projects do not go through peer review and other things. So there is a part of that. But for majority of the users, we say the access to compute should be very closely aligned to the model to access to cloud. Together with the other air site at the University of Cambridge, we designed this federated tool where we said, if someone is coming from a university or research institute, we trust their University of Research Institute ID in granting the application. There were some compliance aspects of things which we designed together with, our funder. But for the most part, it was click, approve kind of thing. And voila, you have access to the system. And that helped for majority of the people who were coming from public cloud environment to get on Isambard very quickly. As a result, in less than 3 months since the Isambard has been fully launched, we have seen a rapid increase from the use from government, from the use from industry, as well as from research and academia. And our funders, they feel empowered to launch different calls for access very quickly. In these 6-7 months, they have issued 5 or 6 different access calls. Some are for very quick projects, some are for long, like AI for more resources, AI for science that are peer reviewed. So yeah, and we have currently running a mixture of big or small projects, like approaching 700 projects and close to, I think, 3,000 users in 6+ months on the ones after scale out of these resources. So it is, for me, like a real democratization of the process because I felt, and there was no need for our community to be like that, but somehow for reasons maybe we could discuss here, the ease of access, reducing barrier to these resources to avoid their community. We have projects from humanities, social sciences, law, linguistics on Isambard-AI. And that is just so gratifying for me that I have done a project where, the reach is so wide. I mean, we are also working very closely with the different important strategic government institute on the same resource. So to me, if we design right now, if you think of it, if I put my technical hat there, the innovation our community has been doing for decades, I mean, at US national labs, all the leadership, it can be so much enhanced if we also co-design the access methods. Again, depending on the mission, it may look different, because that tooling maximize the value of other investment, in my view.
You're listening to Scientific Software Horizons. I'm Mike Bernhardt, and today we're speaking with Dr. Sadaf Alam, Director of Advanced Computing Strategy and Chief Technology Officer at the Bristol Center for Supercomputing. So far, we've been talking about the infrastructure behind modern AI supercomputing. As we pick up the conversation, we'll zoom out just a bit to talk about the science these advanced computing systems make possible. We hope you're enjoying the conversation. Thanks for joining us, and now we'll go back to our hosts, Mike Heroux and Lois Curfman McInnes.
When you think about the students and researchers entering this field today, what capabilities will define the next generation of computational scientists?
So when we started hiring, and as we said, we focused on skills that were not traditionally HPC, because our thesis was that we go for a bigger pool of users or experience and then teach them HPC. So they should have better software engineering skills, have worked on some public cloud environment, familiar with CI/CD pipelines and other things. And these are much common, we can call them software engineering skills that are important. And we had a level of success. Our team is a mix of people, some from background like us, more traditional HPC, but majority have never worked on an HPC center. And so for a skills and experience point of view, I feel like we shouldn't grow the pool bigger for HPC by, and I think AI is helping here. And I'll come back to AI in a little bit. From the scientific computing and user point of view, I noticed at least two different behavior, and which I think I alluded to earlier. So individuals who were coming from other supercomputing, more, let's call them traditional supercomputing center, or they were having big problems the way we set up the system. From an access point of view, because we focused on security quite a lot, because if you make the system more accessible, it means that you have to add additional layers of security for access. And they didn't like, SSH certificates that expire in 12 hours and things like that. So they were not happy. On the other hand, people who have more or less work came from public cloud usage environment, they found it this click, go kind of thing. I'm not saying they do more than that. They set up really complicated pipelines, but that look and feel there was okay. I'm really very positive about new generation, which I will mention in a little bit why. That we bring everyone along. We don't leave people behind. And there is a big danger if it is not done carefully because of the huge investment in AI and all the is sucking out all the oxygen from the system. The usage of AI in my team and the people using our system is remarkable. Sometimes it's helpful, more often it is not, because people try to generate now code and scripts online and try running it on your system. I find our new hires so productive in sort of weaving the AI tooling in problem solving. So I find it like some of our employees and also users, they learn and get on to things that if I look back at my career as a postdoc at Oak Ridge, it took me like several months to acquire. So I would say in terms of acquiring skills or people, I know there is, again, a very black and white concept, like not demonizing, but being very careful with usage of these tools. I personally believe, in looking at the limited evidence I have both from our user community and the new team members, it can be used with caution for reducing and where we could be more inclusive. And I personally think the AI community is more diverse in more than one dimension that are traditional HPC communities.
Thanks, Sadaf. Quite interesting insights. Next, we'd like to consider global collaboration issues. Supercomputing has always been international, and we're wondering, how important will global collaboration be between computing centers for tackling the next generation of scientific challenges?
Really, really, really very important. And, we engage with, because we just don't have enough, we won't have enough resources to do everything. So it is super, really, I don't know, I can use the proper way to emphasize how important it has been throughout my career and going forward, especially with the rate of change and a pace of change. It's so important to learn from each other and continue maintaining and growing these collaborations. So if I can just personally reflect, so I didn't work in the US for a very long time, but when I joined, and that happened throughout my career, supercomputing was growing fast, both in the US and also in Switzerland, which meant that I have had opportunities to, in the US system, work with different labs and also with NSF. And then in Switzerland, also technically Switzerland is not part of EU, but a number of European projects and collaboration. And while, collaborating has some overheads, I think then it is a net positive for us in terms of personal growth, career growth, but also in finding solutions that are more sustainable and adaptable. In just look at the cloud software stack, there are a number of proprietary elements, but there are a lot of community elements. In fact, one of the projects I'm working on is sovereign supercomputing stack. It has elements that are already part of Linux High Performance Software Foundation. So as a community, I feel like, especially people who are in the senior roles, to make sure that they are supported, they are nurtured, and if at all possible, which I know this time and age could be very, very challenging, find common ways to support joint projects at some sense, and at a minimum make sure that we are supporting the initiatives and communities that help us grow. And because I'm quite concerned about closing things up in certain ways. I think we should really make sure, if people want to use something closed source, that's their call. I have no problem. But I feel like as a global community of digital research infrastructure provider, whether it's for AI, HPC, quantum, or something else, we should have options and choices in open source, open standards, and that cannot happen at one center, one site, one institution. It ought to be a collaborative global effort. Yeah, so in my role at Bristol, that's one of the things I mostly focus on. And it's not easy, especially after COVID and other things, and other, let's call it, changes. It is probably in some cases more difficult. And that's why I'm happy to be on this podcast, because it gives a different perspective from my experience and my point of view, which may have some overlaps and some differences from if you ask the same perspective from someone in a different region, different experience. It doesn't make one person's perspective right or wrong. It means that where we have commonalities and overlap, how do we make sure they grow? But when we have differentiation, it's our value add. It's not differentiation because we differ with each other. It is a differentiator based on, a programmatic mission or other needs. Global, in some sense, we need to find more ways, which I think you, Lois, and Mike, you have tremendously helped us in setting some of these large-scale collaborations around software, scientists of software stack.
Thank you. And we also really appreciate the collaboration we've had with you over the years. Well, I'd like to get a sense of your own personal motivation. So you've worked on, some of the world's most advanced computing infrastructure. What keeps you excited about this field today?
I am sometimes surprised, to be very honest, why I'm so still excited and so motivated about getting things done. My PhD was between two fields. So I have a computer science background, but my PhD was funded through particle physics for a co-design projects looking at quantum thermodynamics. And it initially, so that kind of disturbs something in the sense of science, being part of something bigger and solving a bigger problem, scientific, public good, other thing. And then you end up working with some amazing people, whether they are on the domain side, researchers, scientists, people individuals working on optimizing algorithms. So that is almost infatuating. I don't know how to say it like that. And I thought it was like that during my PhD with that field, or during when I was at Oak Ridge working with some computational physicists, and then when I was in Switzerland working, mainly with weather and climate, but other co-design applications. So I think one of the main things, and then on this Isambard-AI project, working with the AI Security Institute, which have completely different mandate. But the problems they are trying to solve, they are, of course, public good. And then you just learn so much from them. And like I said, the international collaboration project, and anyone who likes learning and ready to be challenged for their beliefs, I think that's probably something that at a personal level is exciting. And then I was preparing a talk for a student lecture type of thing. And so I came across with this quote from a French, playwright and poet is called Molière. He says something: the greater the obstacle, the more glory in overcoming it. And to me, glory is okay. Some maybe think it's a personal gratification and get to know great people. So every project I look at, which was like a total harebrained thing to do, when you started, when it gets done, it's just something. Which is difficult to explain. Like when we started Isambard-AI, no data center, no team, we said we could spectacularly fail, but we know we had good support. Our funders were there. University was supporting. We had really great co-design use cases, good collaboration with vendors also. We came through. It wasn't easy at times. It was really, really challenging. But I think that's the way to sort of look at it. Yeah, there are obstacles, and the bigger they are, the more fun they are once you are on the other side, is probably the way to do it. But it is not about technology. I think at the end of the day, for me, it's about people.
Thanks for your insights, Sadaf. I think we can all relate to those comments. So here's a final question. Suppose we were having this conversation again in 10 years. what breakthrough in computing or in science enabled by computing would you most hope to be talking about?
There is a part of me that would like to predict what it should be, and there is a part of me that would like to be totally surprised. I don't know which one will make me happier. Again, if I narrow it down to one criteria, which is something quite non-technical and totally bland, but it comes from a public good perspective kind of thing where we end up using taxpayer money for these resources. The TCOs of infrastructure we are building and the impact on our environment is something that really concerns me. I would like us to be talking about something that breaks that cycle, that we have found an accelerator. I'm not going to say it should be quantum or something. We have found hardware, software, some ways that where we are really not doing scientific computing with the same model, where there is really the level of increases for TCO and environmental impacts are not sustainable. I think that's one of those things. The other thing which I didn't mention, and which is probably important from a scientific field point of view, it relates to health and medical sciences. So with AI, so one of the biggest users of AI across range are medical and health related topics from different areas. But there is a lot that could be done on Isambard-AI if we support a level of privacy, security, isolation, multi-tenancy model is not quite there. And these are one of the research projects we're working on. And I would really like to see this problem is kind of solved in edge and cloud world through confidential computing and some of these things. So I would really like to be, and I hope not in 10 years, way sooner than that, we could accommodate those without, workflows, policy, and technologies without losing a lot of performance. So, but that to me should happen in less than 5 years. So,
thanks very much for sharing your insights with us, Sadaf. We really appreciate your participation in the Scientific Software Horizons podcast.
Yes, thank you very much. It's been a real privilege talking with you today.
Yeah, thank you for for this opportunity.
Well, that's a wrap for episode 2 of Scientific Software Horizons. A sincere thank you to our special guest, Dr. Sadaf Alam. Thanks to our hosts, Mike Heroux and Lois Curfman McInnes, and our producer, the very talented Justin Burrow. We'd like to encourage all of our listeners to please tell your colleagues about this podcast and remind them to follow us on our Scientific Software Horizons LinkedIn page to get updates on future episodes, special programs, and other activities. Until the next episode, for Scientific Software Horizons, I'm Mike Bernhardt.